Okay, today we're going to do a short video on Autotune, lambda, lambda correction, lambda target error, what these values mean, and how you should use them. Okay, first off, we're going to show you our map. So this is a throttle position based map over RPM, standard VE values, and there's no 4D axis. The auto-tune feature, as it relates to the data logger, when you shift left click a section of the graph and then you shift left click somewhere else on the graph and it highlights it green, you can right click on this and you can auto-tune this VE. Now, what does that mean? So when you apply this correction to the map, it only works with our regular 3D map. So you have TPS manifold pressure as your axis and RPM usually as this axis. And Autotune works perfectly in this scenario. So manifold pressure versus RPM, throttle position versus RPM, Autotune will work perfectly in this scenario. Now, why am I saying this more than once? We often have compensation tables that affect our tune. We often have nitrous that affects our tune. What will happen with nitrous is because your stages of nitrous are actually changing the fueling based upon what you've asked it to do. And in this case, we're using 100% of whatever the ECU calculates. So if the ECU is calculating we need 10 milliseconds of fuel at this percentage of nitrous solenoid duty, then we're going to get 100% of that 10 milliseconds. Okay? So Autotune is not going to work perfectly in this situation. It might not work, might not give you your desired result at all, because it's going to tune the fuel table, your main VE table, for the error, not the nitrous table. So if nitrous is what's causing your problem to be too rich or too lean, fixing the main VE table is not going to be what you want to do. Okay. So what do we do in that situation? Well, the first thing you need to do, I'll clear this off, is this line right here is how much fuel, how much in percentage is the ECU correcting overall to attain the target air-fuel ratio. So right now, in this example, it's adding 8.6%, and that's because of this lean spike back here above target, okay? And in this instance, we could speed the reaction of the O2 up, but these settings work pretty well. So as you can see, as the O2, as the lambda gets richer and it starts pulling the corrections out, we bottom out at negative 25%. So that's the maximum correction, or that's the most we can lean the lambda out. We're taking 25% out. But you notice we're still below our target. So even though we're taking 25% out, we're still below our target. So Autotune won't work for this. But if you want to know how to analyze this and how to tune for this and what percentages are to calculate for this, we're taking 25% out and we're still, I would say, 5 to 8% away from our target. How do I know we're 5 to 8% away from our target? Because we have values up here that are called lambda target error. So target error is just the difference between our target and our actual lambda. So we are 0.51 lambda and our target is 0.58 lambda. you subtract one from the other and divide by your target, and that'll get you your percentage. So in this case, I'm not going to give you the exact math on the screen, but if I were tuning this motorcycle, I would say 25 is our correction, minus 25%, and then I would lean it out another 5% on top of that. So that would mean I need to take out 30% of nitrous or 30% of fuel somewhere in the map to correct this problem. Same thing up here. We're at 21% negative corrections. That means we're pulling 21% of the fuel away. We are 0.51 lambda, our target's 0.58, so our lambda error is, let's just round it up to 0.7. So that's roughly, another 10%. So I would lean that area out 25% because we're already correcting at 21. That's only going to get us, 21% is only going to get us here because that's what we're taking out now. I want to be here. So to go from here to here, I need to go another 10% on top of the 21 I'm taking out. So we're working towards getting a value in the data logger that would help you with this table. There's no way to auto-tune when you've got extra tables, extra fuel tables, nitrous correction tables. There's just no way to auto-tune all of that. So just in recapping what we've discussed, Autotune VE. So when you select a section of the data log and you right click and you want to Autotune VE, that is only going to work on a 2D fuel table, VE table, like we have in our example here, with normal throttle position, manifold pressure, and RPM style axis with no 4D. So it's going to work just like this. It would work great with no nitrous. So basically an all motor pass or a turbo pass, no nitrous. So those are the stipulations in having Autotune VE work perfectly. All right, I hope this helps, and thanks for choosing Max ECU.